everyone, it's Justin again. In the last video, you learned how to multiply any monomial times a polynomial. But we also know that there are plenty of polynomials that are bigger than monomials, so we need to know how to multiply those too. In this video, you're going to learn how to do exactly that. By the end of this lesson, you will be able to multiply binomials and other polynomials together. We'll be using the same grid format that we learned in the last video. So first, we'll quickly review how to multiply polynomials by monomials, and then expand that idea to multiplying binomials instead. I'll work out 2 examples while you take notes, then I'll give you an example to try yourself. At this point, we know that to multiply a monomial like 3x squared times a longer polynomial like x plus 5, we can envision the multiplication being distributed across a grid with a single row. But here's where it gets more complicated. If we instead need to multiply 2 binomials, then our grid has to match 2 terms times 2 terms for a total of 4 grid spaces. Each of these spaces is the intersection of 2 multiplying terms. 3x squared times x, 3x squared times 5, negative 2x times x, and negative 2x times 5. We're going to need a little more room for this next part, so let's just move that off to the side for now. We already know from before that this grid gives us all the terms of our product, a brand new polynomial. But do you see what I see? There are 2 like terms here. When we multiplied the 2 binomials, there were 2 spaces that resulted in x squared terms. X squared times a constant and x times x. Even though they appeared in 2 separate spaces, we could combine these like terms and get 13x squared. When multiplying polynomials, highlighting or coloring like terms together this way can really help keep track of them. When we're done multiplying and combining, the product of our 2 polynomials is 3x cubed plus 13x squared minus 10x. Let's try a couple more examples. X to the 4th minus 3x squared times 2x minus 5. First, let's set up our grid, 2 terms by 2 terms, which will create a grid with 4 spaces. Now we multiply for each space. X to the 4th times 2x is 2x to the 5th. X to the 4th times negative 5 is negative 5x to the 4th. Negative 3x squared times 2x is negative 6x cubed. And negative 3x squared times negative 5 is positive 15x squared. In the first example, we had like terms that had to be combined, but not this time. None of these terms can be combined with each other, so the product of this multiplication is 2x to the 5th minus 5x to the 4th minus 6x cubed plus 15x squared. Now, it's your turn to try. Ready? I know what you're thinking. But Justin, we haven't done one like this before. But that's the thing. Now that you know how to multiply binomials, you can do any polynomial multiplication. The only thing that changes is the number of spaces in the grid. Pause the video now and see if you can use what you already know to figure this one out. If you think you got the answer, awesome. And if you got stuck, that's okay too. That's what practice is for. So let's work through it together now. This is a trinomial times a binomial, which will give us 6 spaces in our grid. There are a lot of negatives here, so we need to be careful. Negative 3x cubed times 2x, negative 3x cubed times negative 4, negative 5x squared times 2x, negative 5x squared times negative 4, 2x times 2x, and 2x times negative 4. We've got a bunch of terms here, but some of them might combine. There's only one x to the 4th term, so we don't have to combine anything there. We have 2 x cubed terms, and when we combine those, we get plus 2x cubed. There are also 2x squared terms, which combine to make plus 24x squared. And finally, we have this lonely x term, which has nothing to combine with. After multiplying these 2 polynomials, the final product is negative 6x to the 4th plus 2x cubed plus 24x squared minus 8x. Now you can multiply any polynomials just by drawing a grid. But the grid takes up a lot of room, so we can't rely on that forever. In the next lesson, we're going to leave the grids behind and start taking a more algebraic approach to multiplying polynomials. See you then!